there's no better time to work on this than in the summer. So, what I'd like you to do is give me the answers as quickly as you can without a calculator in front of you.
Okay. It's -6.
Next. I understand, especially since you took geometry last year. But there's no subject matter more fundamental to your success in math than this. Trust me. Just trust me.
Yeah. -2.
It's -16. In other words, when you're adding two negative numbers, when you're adding two negative numbers, it's like adding two positive numbers, only you stick a negative sign with it.
Yeah. Okay.
About this one.
+15?
It's +3. And here's how this works. Here, let me do something here. Well, not going to be able to do it. Can't use the sketcher right now. What I tell everybody to do, what usually gives students problems is subtraction. And I know this sounds really, really basic to you, and you probably are saying, I have a calculator, what do I need to do this for? Well, the fact of the matter is that when you're solving equations, you can't really use a calculator for every single step. And you are faced with 5 or 6 steps that involve adding, subtracting, multiplying, or dividing both positive and negative numbers. So you have to be absolutely proficient at this. You do not want to have to use a calculator for this problem because you're going to get so many of these that you'd have to almost wear the calculator in your hand. And you don't want to do that. That is no way to begin math. You just want to get good at this, okay? And by good, I mean 99%. So let me do one thing, first of all, which is I'm going to copy this and I'm going to paste it into the chat room of GoToMeeting.
Okay.
You should see it. You see it?
Yeah, I see it.
Click on that.
Okay.
Now it should open in your browser the same page that you're looking at in my computer. May not be the exact same numbers, but it should be the same page. In other words, it should say flashcards, positive and negative numbers. Now, it's a little tricky sometimes because you're looking at my screen. So you kind of have to minimize that to see what happens in your screen. Okay. But anyway, if you can get that to show in a browser on your computer, then save it as a favorite so you can get back to it. And I want you to work on this summer. In other words, you don't have to work on it a lot. Spend maybe 5 or 10 minutes every day. Just get to a point in time where you don't make any mistakes anymore. Okay? And that's the secret. If you only get 90% proficient, it's not good enough. What's going to happen is you're going to use your calculator if you're only 90% accurate. You're just always going to use your calculator. And when you do that, then you're never going to remember it again. And that's what happens to people, is that because everybody has calculators, they use them to be perfect. They don't want to make a mistake in their math, so they use a calculator. But it's really, really important that you be able to do these single-digit numbers without a calculator. It just is.
Okay.
It's the biggest problem I face as a high school math tutor. I keep getting people to get to Algebra 2, even pre-calc and trigonometry, even calculus, and they haven't mastered this part of math, and it makes it really, really tough for them. So the very first thing, I'm not going to spend our whole session tonight on this, but mainly I wanted to point out this website because this isn't something that I can really help you with. I mean, this is something you have to do on your own. You just have to get good at your multiplication tables, basically. And it's not just multiplication, it's subtraction and addition of positive and negative numbers. And you can see that it's not that easy. It's tough. This one is, okay, what I tell everybody is change all, here, let's see if my thing is working again. Yeah, it's working now, good. That means I can write on my screen. Okay. So, there's 3 dashes you're looking at. Which dash is the subtraction sign?
The middle one?
Yeah, that one right there. What confuses people about this is they really get confused with subtraction signs and negative signs. So, every time you see a subtraction sign, what I want you to do is change it to an addition problem. In other words, change it to an addition, and once I've done that, I have to change the sign of what was being subtracted. So instead of a negative 9, it now becomes a positive 9. Now the problem becomes this, minus 6 plus 9. What's that? What's minus 6 plus 9? Okay, here's the rule. When you are adding, what we're doing here is adding, okay? When you are adding a positive number to a negative number, you subtract the two numbers, that's 3, and you put the sign of the bigger number. Well, 9's bigger than 6, so I'm going to put a plus on it. That's how you do it. Okay. All right, so that is 3. Just verbalize your answer and I'll type it in.
0.
Change that subtraction to an addition.
Addition, 12.
Multiplication.
Negative 4. 1.
Good. On these multiplication and division, give me the sign first, right off the get-go. Before you do any math, tell me the sign. That's always the way to do it.
Okay. Answer is -2.
Yes.
Yes. 1.
Oh, I think we just had that one. Okay.
Yeah.
Now,
7.
this is a subtraction problem, but you don't need to change the sign on this one. In other words, as long as it's a number minus a smaller number, and they're both positive numbers, then the best way to do these is straight subtraction.
Yeah.
Okay, how about this one? Okay, so this one becomes, we're going to change the subtraction to addition. The moment I do that, I got to change all the signs on whatever's in the parentheses. So that's got to become that. Okay, so now we have minus 12 plus 4. Remember, I'm adding a positive number to a negative number. Subtract the two numbers and put the sign of the bigger number. What's the answer?
Negative 8, sorry.
I'm sorry? What?
Negative 8.
Yeah. Whoops, hold on a second. I got to do it in this screen. Okay, go ahead.
Is it
change the negative sign to a positive.
13.
Give me the sign first.
It is negative 14. 4. 121.
Good, you know, and I don't even expect you to know double digit stuff. They'll have one in here every now and then. Don't worry about these. If you don't know these, don't worry about it. What I want you to do is be able to do single digit stuff without a calculator.
Okay, 7.
Sign first. Sign first.
Okay, 8.
No, sign first.
Oh, sorry. Negative 8.
No.
Oh, no.
Negative divided by a negative is a positive. In other words, that's why I want you to always give me the sign first, is because that's the first step in the thought process. You got to know that negative divided by negative is positive, or negative times negative is positive. Okay?
7.
It's 7, exactly.
2.
Yeah. Sign first.
1.
Good.
Negative 49.
All right. I don't want to spend any more of our session doing this, because this is something that you really need. The only way you're going to get perfect or 99% perfect is just to practice. You know, treat it like a video game. Whatever you got to do. Whatever you got to do to master this, you need to do it. Okay? Now, let's have a look at what they have to say about algebra. I might as well use them, not me. What'd you get as a grade in geometry, Brandon?
C.
About Algebra 1.
C.
Okay. Maybe it'd be easier if I pull some out of my book. I think that's going to be the easiest. Hold on a second. Let me find some good stuff here. All right. I want you to evaluate. Well, hold on. Screwed up somewhere. This is a function. And I want you to evaluate it when x equals minus 2. So what would I do?
You put in the negative 2
Okay.
in the x's.
Read the next line to me as to what I would do. Yes, that's exactly what you do. But the way you do it is important. So that's why I want you to read me the next line.
Negative 3 parentheses negative 2.
Squared.
Power 2.
Squared. Okay, that's good. You expressed that perfectly. Okay.
Subtract 5 parentheses negative 2 plus 7.
Now, this is a perfect example of how many little calculations you have to do.
Yeah.
This is what algebra is all about. And you don't want to pull out a calculator to square negative 2. You don't want to pull out a calculator to do any of this. You still there, Brandon?
Yeah.
Can you hear me?
Yeah, I'm sorry.
I'm getting an incoming call here. I'm going to answer or not answer. Okay, as long as I didn't lose you. Okay, read the next line. In other words, this is always what you want to write. Okay? Don't ever do any of this math in your head. That's the mistake everybody makes. If you write it strictly as a substitution and then simplify it. Okay? And let's do this part next. In other words, you got to do everything in the order of PEMDAS. Exponentials you do first. So what's the next line going to be?
Negative 3 parentheses negative 4.
What's negative 2 squared? Negative 2 times negative 2. Sign first.
Oh, sorry, 4. Just 4. Positive 4.
What's the next thing?
Subtract negative 10.
So if I'm subtracting a negative 10, what's that the same as?
Minus plus 10.
Because here's what I had, is I was subtracting a negative 10, right? Well, those two negative signs turn into a positive sign. So you end up with plus 10 plus 7. Now one last simplification, minus 12 plus 10 plus 7. Again, you can start to see how important, just in this problem alone, we had like 8 little calculations. We had 1, we had 2, we had 3, we had 4, and then we had to add that, and that. So there were 5 little calculations. You don't want to have to use your calculator to do all of those. And that's what algebra is all about. This is almost the epitome of algebra. Or when you're solving equations, you're doing all of these single-digit operations. And you don't want to have to use a calculator. Okay, hold on. Let me look for some more stuff here. All right, how about this? I'm just shooting in the dark here, if you understand, Brandon. If I'm too easy for you, I apologize. If I'm too hard, I apologize. But until I know what you need, I'm just going to kind of have to pick and see whether you know how to do this stuff or not.
Okay.
What's that simplified to?
Sorry.
3n squared plus n minus n squared. What's that turn into? Combine like terms.
what is the,
Okay, hold on. There's a like term, there's a like term. Combine those two.
yeah,
What's 3n squared minus 1n squared?
2n.
Mm-hmm. And I still got that plus n, and I can't do anything with that.
Yeah.
Factor that. Think greatest common factor. What's the greatest common factor that you can take out of those?
1.
N.
And, yeah.
In other words, after I've factored it, this is what I get. And the reason I know is because if I multiply this n times the 2n plus 1, I get 2n squared plus n. Okay? So, let's talk factoring. That's always a good place to start because that's a big subject and it's absolutely a subject that you need to be competent in. Okay? So, let's talk greatest common factor. This is the priority that you want to use when you're factoring stuff. You want to look for greatest common factor first. Okay? Let me give you another example of greatest common factor. Take the greatest common factor out of that.
2.
Don't forget the variable.
Oh.
It's 2x.
Yeah, 2x, yeah.
And remember what the definition of greatest common factor is. Greatest common factor means if it really is 2x, then I got to be able to divide both terms by 2x. And that's what's left over in the parentheses. In other words, this is going to be x plus 2, and I'm taking a 2x out. So that's how I do greatest common factor.
Yeah.
Okay? That, when I say the priority of these, is when you go to factor an expression, start with greatest common factor. If you can't do greatest common factor, then you can't do it. Next case is dopes, difference of perfect squares. That's the thing you check next. Okay? X squared minus 25. That's a perfect square. That's a perfect square, and they are being subtracted. That's why it's called difference of perfect squares. And that always factors into x minus 5 times x plus 5. And another way to do that would be a squared minus b squared. There's the difference of perfect squares. Always going to be a minus b times what?
A plus B.
Okay. Let me give you one. Factor that.
Okay,
It's always the square root of that minus the square root of that times the conjugate, which in this case means x minus 3 times what? Second half is automatic. You don't have to ever figure that out. What's the conjugate of x minus 3?
X plus 3.
That's difference of perfect squares. Okay? Now, I want to erase some of this stuff because I want to put it all on one page. So I'm going to leave difference of perfect squares up there because the order and the priority of these is very important. Every time you go to factor an expression, you want to do it in this order. You want to first see if there's any greatest common factor, then check if it's difference of perfect squares, and finally you have quadratic factoring. I'm just going to call it this. This is the toughest, and this is what gives people problems. Now, notice this expression, x squared plus 7x plus 10. Is there a, first thing you do, is there a greatest common factor?
No.
That's right. There is nothing you can factor out of all three terms. You can't factor x out, can't factor 7 out, you can't factor 10 out, you can't factor any number or any variable. So there's no greatest common factor. Is it difference of perfect squares? Difference of perfect squares is pretty straightforward. It can only be two terms and they have to both be perfect squares.
Yeah.
So no, this is not difference of perfect squares. So we're down to quadratic factoring. Now, what method have you been taught as to how to do quadratic factoring? You know?
No, I don't know.
Good. Because I hate every method they teach in school. I'm going to show you how to do it, and it's really not that tough. You just have to remember the method. Okay? So, what I'm going to do is break it up into two linear components. X plus or minus something times x plus or minus some other number. And what you're doing when you are factoring a quadratic is the reverse of FOIL. Remember how you FOILed?
Kind of.
Well, let's review FOILing before I go any further. Up here in the left, here, let me change color. Let's multiply x plus 2 times x plus 3. How would you multiply those two together?
The first x goes to the other.
Now hold on. FOIL stands for the first plus the outside plus the inside plus the last. So you got to do those four operations. What do you get when you do the first? What's x times x?
2x.
That's x plus x. X times x is x squared. It's okay. The one thing you got to really be careful about when you're working with variables is to make sure you know whether you're adding or multiplying, because it makes a big difference. Okay? So what's the second? What's the O of FOIL? What are the two outside terms?
It is 3x.
Correct. And I do need a sign in front of that. I cannot ignore to write that sign. Okay? What's the inside term?
2x.
Plus 2x. And what's the last term?
And plus 6.
Okay. If I simplify that, go ahead and simplify that for me. What's it become? In other words, you can always, almost always combine those two terms because they're similar terms.
Yeah. X squared plus 6x.
It's 5x.
I mean 5x.
Because we're adding, we're not multiplying.
Yeah.
Okay? So, when I'm factoring, I'm doing the opposite of that whole process. I'm doing the opposite of FOIL. And that's important to remember. Okay? So the first thing I'm going to do on my x squared plus 7x plus 10, so I'm going to split the x's up. 1x goes there, 1x goes there, because the first step of FOIL is going to multiply those two terms together, and I'm going to get x squared. Second thing I'm going to do is I'm going to determine both signs. In other words, the sign that goes after the x is either a plus or a minus, right? Well, I'm going to figure out both of them. That's my next step in factoring. What do they both have to be? Can they be opposite one another? No, they have to be at least the same. Otherwise, we'd never get a plus 10. Because if the signs were opposite, we'd get a minus 10. Okay? So we know they have to be the same. They're either minus minus or plus plus. And the way we figure it out is we look to the middle term. The middle term is plus, therefore they're both plus. And the third and last step is rather easy. I need factors of 10 that add, because of that plus sign right there, to the number 7. Well, what factors of 10 add to 7?
None.
Okay, let's talk about factoring a number. There's something else you need to be able to do without a calculator. Start with 10 and 1. And now, see if you can cut 10 in half. Well, I can. And I can double 1. So 5 times 2 must be another set of factors. Now, are there any other factors? No, I cannot cut 5 in half. I can't cut it in thirds. I can't cut it in fourths. This is it. 10 and 1 and 5 and 2. Well, which set of factors add to the number 7?
5 and 2.
All right. It's as straightforward and simple as that. Okay, now let me just give you some. They get a little bit harder if there's a negative sign. Let me give you one. Let me think for a second. There's a quadratic. Can I take a greatest common factor out of that?
Yes.
What?
4x.
The first term is not divisible by 4x.
Oh.
Remember, that's the definition of greatest common factor. This has to be true. Every term has to be divisible by this greatest common factor. If it isn't, it's not a greatest common factor. So I can't divide anything by anything greater than 1, and that's not one that you consider. Okay? You're not looking to take 1 out. You're looking to take a number and maybe a variable out. So is there anything that divides into all 3 terms evenly?
No.
Okay, so we can't use greatest common factor. Is a difference of perfect squares?
No.
Okay, means we have to do quadratic factoring. How do I start? What's step 1?
Start with x on both.
Good. In other words, I'm splitting up the x squared. Now, if this were like a 2x squared, then one of these would have to be 2x and the other would have to be x. But what I'm doing is starting off with very elementary quadratics. And trust me, that's all you really have to know how to do. If you can be perfect with these elementary quadratics, and I can certainly teach you how to be perfect with them, it's either 3 or 4 steps, that's it, ever. It's the same 3 or 4 steps every single time. What's the second step? I've done the first step. What's the second step?
Subtracting.
Figure out both signs. That's the step that everybody forgets. I don't know why, because that makes it simple. In other words, if I can figure out both signs, the last step's pretty easy.
Yeah.
What do both signs have to be?
Subtraction.
How can I produce a negative 12? If they're both negative, that's not going to be a negative 12.
Oh. Negative and positive.
There you go. So I know that much for sure. And it does not matter whether I write negative positive or positive negative. Not in these simple ones. Some of the more complex ones, yes, it does matter. And we'll get to those. But you need to get through this first. Okay, now there's the third rule is what? Factors of what that do what? Factors of what, first of all?
Factors of the
12.
the numbers.
Factors of 12. It's always this constant. That's the constant. It's got no variable with it. That's always the third term in these quadratics. So I need factors of 12, but what do those factors have to do?
Have to add up to 4.
Not add. Subtract, because of that, right there, that negative sign that's in front of the 12. That means the factors have to subtract to the number 4. Well, let's look at factors of 12. There's the first one. Give me some others. Cut this in half, double this. What do you get?
Negative 6.
Keep going.
Oh, 3.
Got to give me both factors. 3 times what? I just cut 6 in half, so I got to double 2. That's how you do it. Okay? So those are all the factors of 12. Which set of factors subtract to the number 4? Okay, hold on. Before you go any further, there's one set of factors. Those two numbers subtract to 11. There's another set of factors. What do those two numbers subtract to?
5.
What's 6 minus 2?
4.
There's our answer. Because these two subtract to 1. So our answer is 6 and 2. So that's our step 3, but there is a step 4. Because I got to figure out whether to put the 6 with the minus sign or the plus sign. Well, what you do is you always put the bigger factor, 6, with the sign of the middle term, which is negative. So the 6 goes there, the 2 goes there. And we've just covered quadratic factoring. And if you got perfect at this, you would do fabulous in algebra. So all you got to do is get perfect at this simple problems that I just gave you. I gave you really an easy one where it was only 3 steps, and then I gave you a slightly tougher one which was 4 steps. So I'm going to give you another 4-stepper. And the 4-steppers are always, they have a negative sign in front of the constant. Okay, so let's think of a number here. I'm going to put 20. And let's put positive 8x right there. So, greatest common factor? Yes or no?
No.
Dopes? Yes or no?
No.
Makes it a quadratic. That's the thought process you want to go through every time. First step?
X on both.
Second step?
Negative and positive on both.
Or positive, negative, it doesn't matter. Third step? Verbalize it.
Okay.
Factors of
20
that do what?
that subtract to 8.
Perfect. Okay, let's go look at factors of 20. Start there. Keep going. Give me the rest of them.
10, 5.
10 times 5 is not 20.
Oh, sorry.
In other words, what you did was you cut 20 in half, right?
Yeah.
So you got to double the other one. That's the way you factor.
Yeah.
Okay? Now, I can do it again. I can cut 10 in half. Now I got to double 2. And that's all I can do. That's the only factors. Now, which set of factors subtract to the number 8?
10 and negative 2.
Not negative 2. Just 10 and 2. Don't introduce the signs yet. All three of these steps are without signs. I'm looking for factors of 20 that subtract to positive 8, not negative 8. And it's positive 8 not because of the positive sign in front of the 8. It's always factors of that either add or subtract to that. So we know it's 10 and 2. Where's the 10 go? And where's the 2 go?
The 10 goes to a positive?
Yeah, because the middle term has a positive sign. Okay?
Yeah.
Now, if I wanted to check my factoring here, then I'm going to use FOIL and multiply these things back together again, right? So, if I do that times that, that's x squared. If I do that times that, that's minus 2x. If I do this times that, that's plus 10x. And if I do the number times the number, that's minus 20. And then if I simplify everything, I get this, which is what I started with. In other words, that equals that. And what that tells me is I factored it properly. And you don't always have to do this check. Once you get a little bit better at factoring, then you might not want to spend the time checking it. But if somebody put a gun to your head and said, factor this correctly, I guarantee you're going to check that. In other words, if your life depended on it, you're going to check it. A lot of math. You kind of have to make a decision somewhere along the line is, do I check my answer or am I confident enough in it that I can just go with it? All right, let me give you one more that's really no more difficult. It's just a little tricky. Can't do greatest common factor, can't do dopes. Therefore, it's this kind of factoring, quadratic. Do this for me.
Okay, x of both positive and negative. Yeah.
Verbalize the third step.
Okay, so factors of 12.
Good. x. It's always the coefficient that's in front of x. 1, exactly. So it's factors of 12 that subtract to the number 1. Not -1, but the number 1. Okay? In other words, we don't want to get confused by the sign yet. So don't worry about the signs. I mean, you got to worry about this negative in front of the 12 because that tells us whether they need to add or subtract to the coefficient in front of the x. So tell me all the factors of 12.
12, 6.
Give me the other one. When you're giving me factors, you got to give me both of them. 6 and what?
Oh, 6 and 2.
Keep going.
3 and 4.
Okay, and that's it. In other words, I could cut the 4 in half, but then I'd be back to 6 and 2. So I'm looking for different factors. That's the only different factors there are. So which set of factors subtract to the number 1?
4 and -3.
Not -3. 4 and 3. There are no negative signs over there. They're all positive. Everything's positive. I'm just looking for factors of 12 that subtract to a certain number. Okay? So it's 3 and 4 is the answer. Now I got to figure out whether the 3 goes with the plus sign or the 4 goes with the plus sign.
The 4 goes with the plus.
No. The bigger factor, which is 4, right? 4 is bigger than 3. The bigger factor goes with the sign of the middle term. The bigger factor is 4. Sign of the middle term is negative. The 4 goes with the negative. Therefore, the 3 has to go with the positive. Okay? Now, the only reason this was slightly trickier was because there's no 1 there. If we wrote our 1's in, which you could certainly do, it's just convention, algebra convention, that you don't have to write a 1. If the coefficient is 1, you can not put it in there. But that doesn't mean you can forget that there's a 1 in front of that. When you see an x, and it doesn't matter whether it's plus x or minus x, coefficient is 1. Okay, and when you're doing this factoring, that's really critical because you're always talking about factors of that number that either add or subtract to that number.
Okay.
All right. Give you just a few more. We just don't have 5 minutes here, and I don't really want to get into a major another topic. Especially since this is a big topic. I mean, if you could just master factoring, you can't believe how far that's going to take you in algebra. Okay?
Yeah.
So let's just cover a couple more. Greatest common factor?
None.
Difference of perfect squares?
None.
Hold on. That's a perfect square. That's a perfect square. 10 times 10. And that is the difference. They're being subtracted. In other words, if it was x squared plus 100, that's not difference of perfect squares. That's the sum of perfect squares. But this is exactly what Dopes says. Difference of perfect squares. So what does that factor into? I'll give you a hint. X minus something is the first term.
Okay.
It's the square root of this term right there.
10.
That's always what goes there, is whatever the square root of that constant is. And in the second term, you don't have to give any thought to it at all. You just have to put the conjugate What's the conjugate of x minus 10?
X plus 10.
Difference of perfect squares is about as easy as it gets. How about this one?
Yeah.
First of all, is it difference of perfect squares?
No.
Well, 1 is actually a perfect square. 1 times 1 is 1. So the square root of 1 is 1. So what's the answer?
Yeah. X minus 1 plus 1.
And times x plus 1. One more. Is that difference of perfect squares? In other words, in order to answer that question, that has to be a perfect square, that has to be a perfect square, and that has to be subtraction, which it is. First of all, is 4x squared a perfect square?
Yeah.
What's its square root?
2 times 2.
It's 2x. In other words, 2x times 2x is 4x squared. Okay? So this first term is 2x. In other words, the very first term is always the square root of that perfect square. The sign is always negative. What's the next term?
3.
Uh-huh. And then what's the next term in the parentheses?
2x plus 3.
You got it. In other words, once you get the first term, you're done. Basically. You don't have to do any math. You don't have to do anything. Just make sure you've taken the square root of 4x squared, which is 2x. It's got to be a perfect square. In other words, if that was 5x squared, it's not a perfect square. So you wouldn't be able to use dopes. The only time you can ever use dopes is if you just have two terms, they're both perfect square terms, and they're being subtracted. Now, with the work we've put in tonight, you should have a pretty clear understanding of how important it is to be able to do all these small calculations in your head.
Okay.
You don't want to have to go to your calculator and take square root of 100. You just don't. After a while, you want to memorize that 10 times 10 is 100. Therefore, the square root of 100 is 10. And every single problem we did tonight involved lots of tiny, even if you're checking this, you got to multiply that times that. So it's 2x times 2x. And then you got to multiply 2x times 3. And then minus 3 times 2x. And then minus 3 times plus 3. So algebra is just a series of calculations over and over and over. And some equations that you run into you're gonna need like 14 calculations, but they're all single digit ones. But they're all involving multiplying, dividing, adding, and subtracting both positive and negative numbers. So you cannot, if you're not good at that, you're never going to get good at algebra. It's impossible. So that's why I put so much stress on mastering that page that I sent you. Because you just really can't go anywhere without being really good at that stuff. I just firmly believe it. And the fact we're starting in the summer is great. It means we don't have any material that you have to stay caught up with, and we can afford to go to the level we need to go to in order to get you square with algebra.
Yeah.
We may have to go back even further than this, but the one thing I know for certain is you have to be really good at that game of adding, subtracting, multiplying, and dividing positive and negative numbers. And you will. If you just practice it on your own, trust me, you'll get really good at it very quickly. Even without trying. You don't even have to try if you just do it. If you just play 5 minutes a night on that game, it's going to occur naturally. After a couple of weeks, you're going to be excellent at it. All right? All right, Brandon, I won't keep you any longer. Good talking to you again, and I'll talk to you next time.
I'll talk to you next time.
All right, bye-bye.
Bye. Thank you.
You're welcome.